Hello, so this is all about factoring polynomials and being able to use those factored forms to solve a quadratic equation. So, what is factoring? Okay, factoring is about finding the greatest common factor. Greatest common factor. Okay, that means finding the thing that is common amongst all the terms and then factoring that out or pulling that out by undistributing. Okay, so this is called undistributing. Okay, when do we do it? When we have a bunch of terms that have things that are the same. So if we look at these notes here, you'll notice that in the first problem, I have 24x and 48y. Those are two terms, so it's a binomial, two terms. There's an x and a y, so those aren't common. But you will notice that there's a 24 and a 48. They do have things in common. They have numbers in common. So I could say that they have a 2 in common, a 4 in common, a 6 in common. But what I want to do is I want to pull out the biggest one. And I know personally that 24 goes into 48 twice. So what I'm going to do is I'm going to say, okay, 24 goes into both of those terms. So if I pull out a 24, inside the parentheses, or if you think of that as undistributing this thing, what times 24 would equal 24x? Well, that would be x, right, if I multiply those in. And what would be left if I take the 48y and I divide by 24? I would get a plus 2y. So that is the factored form. I'm pulling out the greatest term. In this case, I see a 30, in number 2, I see a 30 m p squared plus m squared p minus 6p. The first thing I look at are the numbers. I have a 30, I have a 1, and I have a negative 6. Really, the only thing I can pull out of there is a 1, so I'm not going to pull that out. Next thing I look at are the variables. I have an m, I have an m squared, but I don't have an m in that third thing, so that's not a common. Then I look at my p's. I have a p squared, I have a p, and I have a p. Those p's are common in every term. So that's the greatest common factor. That is the thing that is in every term. So I'm going to pull out a p. What would be left if I pull out a p? Well, I didn't touch the 30m. I did touch the p squared. So I've taken one p out, so I'm only left with a single p there in that term, because there's two p's with the squared, and if I pull one out, I have one left. I haven't touched the m squared, but I have pulled out this p, so I'm not even going to write it. And then minus 6, I haven't touched the 6, and I pulled that p out. So that would be the factored form of that. It's the same process with 3. I see a q, I see a q to the 4th, q to the 3rd, and a regular q. But I see no common numbers. So what I'm going to do is I'm going to pull out one q. And then if I pull out one q, I'm going to have 3 left over here, 2 left over there, and I'm just going to have 22 left there. Now, I can also pull out multiple things. So for here, I see the 9 and the 3. I know 3 goes into 9, so 3 is a factor. I also see the x squared and the x. That means there is an x in common. Well, now we make my parentheses. If I take 9 divided by 3, I would get 3. I pulled out one x, so I'm left with x in there. Because there's 2 here, and I pulled out 1, so there's only 1 left over. Now I'm left with the minus. Now if you notice, this and this match up. I pulled out a whole term, a 3x. Okay? When I say pull out, I mean divided by. So think of it as this, 3x divided by 3x. Well, 3 divided by 3 is 1. X divided by x, even though I don't know that, it's still 1. So what happens is, this becomes a minus 1. I pulled out that entire term. I still have a minus something. So when I pull out an entire term, it comes out to be minus 1. I can also pull out multiple variables. So in this case, you see a 14, a 42, and a 49. All of those have a common 7. So I'm going to pull out a 7. In my parentheses, I would be left with 2 t something minus 6 t something minus 7. Okay? Now let's look at the t's. I have t to the third, t to the fifth, and t to the fourth. Well, there's 3 t's in the first term, 5 t's in the second term, and 4 t's in the third term. So the lowest number is t to the third. There are 3 common in each of those. So I look at the lowest power. Now, if I pull out 3 t's here, I won't have any left in this first term, so I'm going to leave it just 2 minus. I pull out 3 from the second term, so I'm going to be left with t squared there. And I pull out 3 from the 4 that I had in the last term, I'm just going to be left with 1t. And that would be the factored form of that. So why do I factor? Okay. Sometimes I'm left with groups of things that don't have common at all. Okay, so when do I factor by grouping? If there's an even amount of terms, usually there's going to be 4 in the cases that we're doing. Okay, I pair the terms, and then I factor each pair separately. So then I can combine the remaining terms to solve. Now let me give you an example of that. So in all of these examples, I have 4 terms. So what I'm going to do is I'm going to group them in pairs. You'll notice that the first pair has an x in common, and what will be left is x plus 2. The second pair does not have anything in common. So if they don't have anything in common, I would just put a 1. And I would be left with x plus 2. You'll notice that when I say factor by grouping, these 2 parentheses are going to come out to be exactly the same. So what I do is I combine them to 1. And then this combines down to x plus 1. So if you remember, when we were distributing, or when we found roots, what we would do is we would take the x and we would multiply both x plus 2, both x and the plus 2, which is the same thing that I would do in this step before if I was working back up. And I would also do the 1 times the x and the plus 2, which is the same thing as doing this. So really, I am still undistributing that result. Only now factoring is working the opposite of what we've been doing before. So my final factored form would be x plus 1 and x plus 2. And that would be how I would leave it. Now we're going to go farther with this when we get into the solving piece. Again, for the number 14, I group terms. I look at the terms individually, and I say, what is common in here? Well, in the first parenthesis, there's a 2y common, what would be left when I factor that out is a 3y minus 2. Because I'm taking a 2 out from each one, so I'm dividing the numbers by 2, and I pull out a y from both of those. The second parenthesis has nothing in common. So if they have nothing in common, I'm going to put a plus 1. I'm going to write it as 3y minus 2. Now, you'll all, again, notice that this 3y minus 2 is common. So I'm going to combine those to 1. And I'm going to combine the numbers on the outside to another. And that would be my factored form. In the final case, again, I pair the values. I pull out what's common. What's common in the last one is a 4m. So if I divide 4 by 4, I get 1. And if I pull out an m, I get an m. Plus, I pulled out a 4m, so it's only p left. And in the second parenthesis, I'm pulling out a 3p. 3p. So plus 3p, and my parenthesis would be left with m, because I pulled out the 3 and the p, plus p. Again, I'm left with this m plus p. That is my first parenthesis. That's these two put together, because 1m and m are the same thing. And then my second parenthesis would be the 4m plus the 3p. Now, again, why do I do this? Because we have to solve things. So before we did finding roots. So finding roots would be identifying where it crosses the x-axis. So in this case, x would equal -1 and x would equal 3. Now, I also taught you a method of finding this equation to figure out what this equation would be. And that would be to add 1 on both sides, or -3 in this case, and set these equal to 0. So it would be plus 1 equals 0, and then x minus 3 equals 0. Now I can combine these into x plus 1 times x minus 3 equals 0. Now I told you to ignore the 0 in most cases, just treat it as a y. But in this case, the 0 is very important because that is what we're solving. We need a number in there so that we can solve a quadratic equation. Now, I would distribute or use the box method. You know, the x plus 1 and the x minus 3. This is distributing, so I get x squared plus 1x minus 3x minus 3. So x squared plus 1x minus 3x minus 3. Then I can combine these middle terms. And I'll get x squared minus 2x minus 3 equals 0. This would be my quadratic equation or quadratic function that I could graph and find the roots. Well, for factoring, I'm working backwards. So I'm working from the equation down here, and I'm working backwards to get x equals -1 and x equals 3 in a systematic way by factoring. So this uses what is called the zero product property. So we all know 2 times 0 equals 0. We also know 0 times anything is 0. So what does it mean when it says a times b equals 0? This is what is called the zero product property. It means either a equals 0, b equals 0, or both a equals 0 and b equals 0. So a and b stand for anything. So if a is 0, I know 0 times anything is 0. If b is 0, I know anything times 0 is 0. And I know if they're both 0 and I multiply them, they're going to come out to be 0. That is what is called the zero product property. The reason why we use that is how we solve. So we solve by factoring first. So I'm going to get it equal to 0. You notice that's equal to 0. And then I look at these terms and I say, what's common? Well, what's common is an x. What would be left if I factored out the x, or pulled both these x's out? I would have a 9x plus 1, because there's an invisible 1 in front of that x, if you remember, equals 0. Well, using the zero product property, I know if these two terms multiplied together equal 0, I know either x equals 0 or 9x plus 1 equals 0. And I can solve both equations. This one's already solved. This one, I would write minus 1, divide by 9. I get x equals negative 1/9. So these are my two solutions. My solutions are x equals 0 or negative 1/9. I know those are my two roots, or where those are going to cross the x-axis. And I write them like this. They're not a point, they're just two numbers. Okay, x is either 0 or negative 1/9. So these two examples just use that zero product property, where I split it into two cases, where x equals 0, this first piece, and then the second piece, x plus 3 equals 0. Many of you can just jump to subtracting negative 3 on both sides. So x has 0 or negative 3. Those are my two results. In this case, 3m equals 0 or m minus 4 equals 0. I divide by 3, m again is going to be 0, or add 4, m equals 4. And I could write it like this also, as a valid way of writing an answer. So how do I factor and solve? Well, the first step is to get it equal to 0. So in both of these cases, they do not equal 0. So I would subtract 25t or subtract 28y from both sides. I'm left with 5t squared minus 25t equals 0. The 0 is very important. It needs to equal 0. So now I look for what's common, and I know a 5t, 5 and 25, both have 5 that can divide them, and both have these t's. So I'm going to pull out a 5 and a t, dividing each term by the 5t. I would be left with t minus 5 equals 0. Now, using the zero product property, I would say 5t equals 0 and t minus 5 equals 0. So my final result for this is going to be t is going to either equal 0 or t is going to equal 5 if I solve both of those equations. I would follow the same procedure for the next one. 4y squared minus 28y equals 0. I can then pull out a 4y, because they both have 4 in common and a y. I'd be left with y minus 7 equals 0. So 4y equals 0, or y minus 7 equals 0. So y is either going to be 0 or positive 7. Both valid ways of solving by factoring. So hopefully you have reached this point. You might need some more practice on this, so there are practice problems. Please complete the practice problems and come in with any questions. Check your answers on the website. they will be posted